What if everything you've been told about getting old is completely wrong? What if growing frail, losing your memory, and developing diseases like cancer or Alzheimer's isn't an inevitable part of life, but rather symptoms of something we can actually treat? Welcome back, everyone. Today, we are deep diving into one of the most disruptive, controversial, and deeply hopeful books of our generation, Lifespan: Why We Age and Why We Don't Have to, by Dr. David Sinclair, a leading genetics professor at Harvard Medical School. Sinclair's core thesis is simple, yet it completely flips modern medicine on its head. Aging is a disease. And because it is a disease, it can be treated, delayed, and potentially even reversed.
Medicine wastes billions trying to treat late-stage diseases like heart disease or diabetes individually. Sinclair argues that these are just symptoms of a deeper root cause, aging itself. If we treat the root cause, the symptoms disappear. In this masterclass, we are going to break down this entire book chapter by chapter. We'll look at the incredible new science of why we age, the daily habits you can start doing today to trigger your body's survival circuits, the pills and supplements showing massive promise in labs, and finally, the radical future of humanity, where living healthy to 120 and beyond is completely normal. Grab a notebook, get comfortable, and let's dive in.
Part 1. What we know, the past, and the science. Chapter 1. Viva in Vivo, the information theory of aging.
To understand how to stop aging, we first have to understand why it happens. In Chapter 1, Dr. Sinclair introduces his groundbreaking concept, the information theory of aging. To explain this, he uses a brilliant analogy. Think of your body's biology like a computer system. You have two types of information. 1. The DNA, the hardware. This is your digital information, much like the tracks on a music CD. It stays constant your whole life.
2. The epigenome, the software. This is the analog information. It decides which genes are turned on or off. Think of it like the laser reader that plays the CD. As we get older, our cells experience stress, environmental damage, and DNA breaks. When a cell repairs a DNA break, the software, the epigenome, gets distracted. Over time, it loses its place. Sinclair says aging is simply a loss of biological information. The CD gets scratched, and the laser reader can no longer read the music perfectly. The cell forgets what it's supposed to do, loses its identity, and starts malfunctioning. That malfunction is what we call aging.
Chapter 2. The Disoriented Pianist. In Chapter 2, Sinclair deepens this idea with the analogy of a master pianist. Imagine a cell is like a pianist playing a specific song. A skin cell plays a skin song, and a heart cell plays a heart song. But inside our cells, we have guardian proteins called sirtuins. Sirtuins have two massive jobs. They act as the switches to make sure the pianist plays the right notes, epigenetic control.
They act as emergency EMT workers to repair DNA damage.
When your DNA gets damaged by UV light, pollution, or toxic food, the sirtuins have to leave their piano to go fix the damage. Once they finish the repair, they try to run back to the piano. But over a lifetime of constant cellular emergencies, they get lost. They don't return to the right keys. Suddenly, the skin cell pianist starts playing a few notes of the liver cell song. The cell becomes disoriented. It loses its identity, stops functioning properly, and joins the ranks of aging tissues.
Chapter 3. The Blind Man. Why didn't evolution fix this? Why are we programmed to die? In Chapter 3, Sinclair explains that evolution doesn't actually care about you living a long time. It only cares about you reproducing. He introduces the concept of antagonistic pleiotropy, a fancy scientific phrase that simply means something that helps you when you're young can hurt you when you're old. When we are young, our body's intense drive to grow and reproduce keeps us alive. But once our reproductive years are over, evolution pulls away its protective shield. However, ancient organisms evolved a primitive survival circuit billions of years ago. When food was scarce or life was tough, these organisms didn't grow or reproduce. They spent all their energy surviving and repairing themselves. Sinclair argues that we still have this exact survival circuit hidden inside our DNA. We just need to figure out how to flip the switch manually.
Part 2. What we're learning. The present and actionable advice. Chapter 4. Longevity Now. How to trigger your survival circuit naturally.
Chapter 4. Longevity Now. How to trigger your survival circuit naturally. Now we enter Part 2 of the book. Chapter 4 is all about hormesis, the idea that what doesn't kill your cells makes them stronger. To activate your sirtuins and wake up your cellular defense teams, you must introduce mild, non-lethal stress to your body.
Sinclair focuses on 4 main lifestyle levers. 1. Eat less often. Sinclair isn't talking about starvation or malnutrition. He's talking about frequency. He skips 1 or 2 meals a day, usually practicing intermittent fasting. When your body is hungry, your survival circuit is forced to activate. 2. Limit amino acids. Specifically, lower your meat intake. High amounts of animal protein activate a pathway called mTOR, which tells the cell to grow. We don't want the cell to grow constantly. We want it to pause and repair itself. 3. Exercise hard and fast. You need to push your body to the point of hypoxia, being short of breath. This minor stressor forces cells to create more mitochondria, the energy powerhouses of your cells. 4. Expose yourself to extreme temperatures. Getting uncomfortably cold, cold plunges, or uncomfortably hot, saunas, forces your body to produce heat shock and cold shock proteins, which help repair cellular misfolding.
Chapter 5. A pill to swallow. The longevity molecules.
While lifestyle changes are powerful, Chapter 5 dives into the medical frontier. Chemical compounds that trick our bodies into thinking we are starving or exercising, even when we aren't. Sinclair outlines several molecules currently being heavily researched, some of which he takes himself. NAD+ boosters, NMN and NR. NAD+, nicotinamide adenine dinucleotide, is the fuel that sirtuins run on. Without NAD+, sirtuins are like a sports car with no gas. As we age, our NAD+ levels drop by half. Boosters like NMN, nicotinamide mononucleotide, help restore those levels.
Resveratrol. Found in tiny amounts in red wine, this polyphenol acts like an accelerator pedal for sirtuins, revving up their activity. Metformin, a widely prescribed type 2 diabetes drug. Data shows that diabetics taking metformin often outlive non-diabetics because it mimics calorie restriction and lowers systemic inflammation. Rapamycin, a compound that targets and turns down the mTOR pathway, tricking the body into shifting resource allocation from cell division to deep cellular maintenance.
Chapter 6: Big Steps Forward. Cellular Reprogramming. 1. Cellular senescence. The challenge? Zombie cells. As cells age, some become senescent, meaning they stop dividing but refuse to die. They secrete toxic inflammatory molecules that corrupt surrounding healthy cells. 2. Targeted elimination. The tool? Senolytics. Scientists are developing drugs called senolytics to selectively hunt down and destroy these zombie cells, rejuvenating the surrounding tissue. 3. Resetting the cellular clock. The breakthrough: Yamanaka factors. Sinclair's lab used 3 specific genes, part of the Yamanaka factors, to deliver a genetic reset to damaged optic nerves in blind mice. 4. The clock winds backward. The result: age reversal. The neurons forgot they were old, grew back their connections, and the mice actually regained their sight. The epigenetic clock was literally wound backward. Part 3. Where we're going. The future and ethics. Chapters 7 and 8. The shape of things to come and a brave new world.
As we shift into Part 3, Sinclair addresses the massive elephant in the room. If everyone lives to 120 or 150, won't the planet overpopulate? Won't the economy collapse? Will only the ultra-wealthy afford this? Sinclair tackles these head-on with surprising economic optimism. He points out that the most expensive part of healthcare is the disease period at the end of life, the years spent in nursing homes fighting chronic illnesses. By extending our health span, the years we live free from disease, to match our lifespan, we save trillions of dollars globally. Imagine a world where an 80-year-old has the vitality of a 40-year-old, can continue working, paying taxes, mentoring the youth, and doesn't require constant, expensive medical intervention. Longevity isn't a burden, it's an economic dividend.
Chapter 9. The next chapter. David Sinclair's personal routine. To wrap up the chapters, Sinclair shares exactly what he personally does based on his research. Disclaimer: he is a scientist, not a physician, and this is not medical advice. Here is a snapshot of his daily protocol. Takes 1 gram of NMN and 1 gram of resveratrol every morning with homemade yogurt. Takes 1 gram of metformin in the evening. Takes a daily dose of vitamin D3, vitamin K2, and 83 milligrams of aspirin. Skips breakfast and lunch. Drinks a lot of green tea and water. Eats a plant-centric diet, avoiding sugar, bread, and red meat. Walks a lot, takes stairs, and works out with his son at the gym. Uses a sauna, followed by a cold plunge weekly.
Ultimately, Lifespan is not just a book about science. It is an invitation to reimagine what a human life can look like. It challenges us to stop accepting decline as a done deal and to start treating our bodies like the incredibly adaptive, self-healing systems they truly are. If there is one key takeaway from David Sinclair's work, it's this: the small choices you make today, what you eat, when you eat, how you move, and how you handle comfort, directly change how long you will be around to love your family, pursue your dreams, and see the future.
Thank you so much for sticking through this masterclass. If you found this summary valuable, please hit that subscribe button. Leave a comment letting me know which habit you're going to try first, and share this video with someone you want to see live a long, healthy life. Until next time, stay curious, stay healthy, and I'll see you in the next summary.